If you fly from London to New York, it takes on average 8 hours and 15 minutes. But flying in the other direction, from New York to London, takes just 7 hours. And no, that's not because the planet is spinning underneath you. In this video, we're going to talk about why that is, and why those flights have been getting bumpier. And it's sponsored by Brilliant. It might feel like the atmosphere just consists of random motion and weather patterns, but there are specific patterns that either recur again and again or are permanent features of the atmosphere. One of the most interesting of these is the jet stream.
So the jet stream is a big kind of current of air. Right, it moves around the globe. It's like a kind of a river of air, but up in the atmosphere. And it's strongest kind of quite high up, so about the level where planes fly, about 10 kilometers or so up. That's where it's strongest, but it does kind of stretch all the way down to the ground.
That's Professor Tim Wollings of the University of Oxford's physics department, who quite literally wrote the book on the jet stream.
So roughly, Earth has kind of one jet stream in each hemisphere. Kind of in the middle latitudes, like at 3040 north and 3040 south, you have these big currents of air going round and round. When you kind of zoom into the details, there's actually a few different structures in there that are kind of merged together. So in the tropics, we have something called the Hadley cell, where warm air kind of rises up over the equator and then moves polewards. And it's that polewards movement of air higher up in the atmosphere that leads to the subtropical jet. And that's really like the ice skater effect. So as that air is moving away from the equator, as the air gets closer to the axis there, it just spins faster. And that's the kind of most basic mechanism that gives us jets.
Now, I want to be very clear about something. The jet stream is not the same thing as the Gulf Stream. The Gulf Stream is a current of water in the Atlantic Ocean that warms up Western Europe. For the time being. I may need to make a video about that. The jet stream is in the atmosphere and is an entirely different phenomenon. And it's also why you can fly from New York to London faster than the other way around.
The core of the jet stream, so the center of the jet stream with the fastest speeds, is at altitudes of 35,000 feet, maybe 40,000 feet. The most common influence really of these jet streams on aviation is headwinds and tailwinds. You get a free boost to your ground speed if you're in a tailwind, which is the wind pushing up towards the back of the plane, and conversely there's a penalty if you're in a headwind, which is flying into the wind's blowing towards the front of the aircraft. So for example, if you're in an aircraft which has an airspeed of 600 miles an hour, if it's flying into a headwind of 200 miles an hour, that's going to slow it down and its ground speed is only going to be 400 miles an hour. Conversely, if it's enjoying the benefits of a 200 mile an hour tailwind, that will add to its speed and the ground speed will then be 800 miles an hour.
And because the jet stream flows from west to east, it provides a tailwind when traveling east. Hence why those flights are faster. But the jet stream is also the reason why those flights can be bumpy. You've probably heard of turbulence. It's a property of lots of fluids, unpredictable, small-scale, rapid changes in the pressure and velocity in the fluid. Describing it is actually one of the big unsolved problems in physics, if you want some homework.
That's chaos theory.
With aviation specifically, turbulence refers to the turbulent effects in the fluid of the atmosphere that the plane is flying through, and, of course, the effect that turbulence has on a plane.
Turbulence is everywhere in fluids. It's random swirling, what we call eddies or vortices. And what happens in the atmosphere is, well, they push up and down on the airframe, on the wings of the aircraft. And if you have a turbulent eddy or current of the right size, it can move the plane up and down rapidly. There are different kinds of turbulence in the atmosphere. Flying over a mountain range, for example, will usually be turbulent because the air blowing over the mountains generates waves and turbulence. Flying through a storm is obviously turbulent because we have rising warm air in the what we call convection pushing up against the wings of the plane. But there's a third kind of turbulence which is invisible. It's called clear air turbulence. It's my favorite kind of turbulence. It's what I've been studying for 20 years. And it's invisible to satellites. It's invisible to the weather radar in the cockpit. And the pilots can't see it with their naked eyes. It's truly invisible. That's why we call it clear air turbulence.
Clear air turbulence has nothing to do with storms or clouds. It's created by wind shear. That's the difference in wind speed at different levels in the jet stream. though clear air turbulence can be created through other means too.
And there's 3 times as much of this turbulence in the jet stream than in the other parts of the atmosphere, so it can be a particularly hazardous kind of turbulence to encounter.
I should also mention that the jet stream is not unique to Earth. Other planets have jet streams too. In fact, some of them have lots more.
Any atmosphere on a rotating planet with a temperature gradient between the equator and the pole can and will generate jet streams. Some of the differences are that the jet streams on other planets can blow a lot faster, so up to 900 miles an hour, for example, on Saturn and Neptune, as opposed to just 200, 250 miles an hour on Earth, so the speeds can be different.
On bigger planets, you tend to have more jet streams. Not just one, but lots of jets kind of lined up side by side as you go north. So Jupiter is a real classic example of this. You can see, everyone knows the kind of banded structure on Jupiter. Underlined with each of those bands will be a jet stream and a kind of a circulation system going with it.
But something that is unique about the Earth's jet stream is that it is changing. It's changing because of, no prizes for guessing, climate change. The jet stream is ultimately created by the temperature difference between the warm equator and the cold poles. In recent decades, of course, the planet has been warming, but it's been doing so unevenly. Due to a process known as Arctic amplification, the poles have been warming up to 3 times faster than the rest of the world. That weakens the temperature gradient and should result in a weaker, wavier, more variable jet stream. But at the same time, more water vapor is being added to the upper troposphere in the tropics.
So the tropics are the real kind of powerhouse of the atmosphere. We know whenever we have an El Nino event, that has a massive impact around the globe. So it's very easy for tropical perturbations to affect the jet stream and higher latitudes. Essentially, as the atmosphere warms, if you warm the surface in the tropics, then as well as warming the air, you're allowing the air to hold more moisture. And then when that moisture precipitates out, that heats the air again. And so, for every degree that you heat the tropical oceans, then once you go up 10 kilometers in the atmosphere, you've heated it by 1.6 degrees, 1.8 degrees, something like that.
And what that is doing is it's strengthening the north-south temperature difference across the upper part of the jet stream.
Many of the models actually suggest the jet should become kind of quite straight and strong and extend deeper into Europe. In that case in particular, it's certainly not expected to get wavier.
That change in the vertical profile, the shape of the jet stream, has resulted in an increase in clear air turbulence in recent decades. And that is what Professor Williams has been studying.
In the upper atmosphere, the jet stream is becoming more sheared. So we see very clearly in satellite observations since the 1970s that the amount of wind shear in the Atlantic jet stream has increased by 15%. That's really a massive change in my lifetime, in just about 4 decades. As I've said, that's where aircraft fly. It's also where a lot of turbulence is, and clear air turbulence is generated by wind shear. So stronger wind shear means more turbulence. And indeed, when we look at turbulence records, clear air turbulence, and diagnose it from atmospheric observations, we see 55% more severe clear air turbulence today than 4 decades ago.
So if you've noticed that your flights have been bumpier recently, that's because of us humans. We've tipped the scales in the atmosphere, warming the Arctic, adding moisture to the air in the tropics, and changing the shape of the jet stream, resulting in more turbulence. It's a microcosm of the entire climate crisis. By emitting so much carbon into the atmosphere, including, of course, by flying, we have changed our environment and made our own lives worse. Now the challenge is to change how we interact with that environment, with the consequences of not doing so, making slightly bumpier flights look like peanuts. Oh, thank you.
This video is now on final approach. Please make sure your seat backs and tray tables are in their full upright position, and maybe consider flying a lot less. Pretty bad for the environment.
Did you know that my first video as a full-time YouTuber was this one, about planets in Star Wars, that turned out to be quite a hit, but at the time there was no way of knowing that. And yet, a sponsor was willing to take a chance on me. A sponsor that has continued to work with me most months because I like what they do, and so do people who watch my videos. People keep hearing about them and signing up with my code. If you've got a minute, please have a listen to what they have to offer, because they've sponsored this video, and by signing up to Brilliant, it helps me out in this channel, but it might also help you out. That's because Brilliant is an educational service offering interactive courses in maths, data science, and computer science on their website and app. If you like my videos and you'd like a free and easy way to learn more, Brilliant should be your go-to. Whether you'd like to learn more about how large language models work, or how Spotify recommends you new songs using probability distributions, they've got you covered. I'm delighted to work with Brilliant, not just because they have these interactive courses on really interesting subjects, but because of their approach to education. They stress being an active learner and applying your knowledge and not being afraid to make mistakes. And that, combined with learning at your own pace, I just think creates the ideal environment for learning new skills in STEM subjects, or supporting your learning in a more traditional educational setting. New interactive courses are added every month, and they adapt to which courses they offer you based on your needs, whether you're supporting learning in the classroom or furthering your career by picking up a new data skill. If you like the sound of this, please check out brilliant.org/SimonClark, that'll be linked below, where you can get a 30-day free trial. And if you're one of the first 200 people to go there, you'll also get 20% off an annual subscription. That's brilliant.org/SimonClark to support this channel and to support your own learning. Thanks to Professors Willings and Williams for chatting to me about this subject. I can highly recommend Tim's book if you'd like to learn more about the jet stream. Thanks must also go to the more than 1,000 people who now support me on patreon.com/SimonOxFizz. Those people get early access to videos, they can vote on a video topic a month, and they get exclusive content, including a behind-the-scenes vlog every month. These are the names of my wonderful executive producer patrons, as well as those misguided individuals who choose to support me at even higher levels than that. If you enjoyed the video, please do pop it a like and share it with somebody else who you think may find it interesting. If you'd like some recommended viewing, here's some I made earlier. And that just leaves me to say thank you so much for watching. I'll see you in the next one.